Here's problem number 6 from uh, assignment number 6. Uh, Sketch a complete and accurate graph of this curve, leaving all extremas, inflection points, and asymptotes. Let's talk about the extremas. If y is equal to 1 over x minus 1 over x squared, then let's rewrite that, please, as x to the negative 1 minus x to the negative 2. Then y prime is equal to negative x to the negative 2 minus a negative 2 times x to the negative 3, or negative 1 over x squared plus 2 over x cubed, or negative x plus 2 over x cubed. Now I want that because I want to see that x equals 0 is critical. But of course we know that since this function is not defined there, that something special is going on there. And then also that at x equal 2, there's a critical value because the derivative is equal to 0. So let's go ahead and let's think about what's going on there. When x is equal to 2, we get 1 half minus 1 quarter, which is equal to 1 quarter. So at x is equal to 2, we're at 1 quarter. Now, when x gets bigger than 2, zero, 2, when x is bigger than 2, we've got a negative slope. And when x is between 0 and 2, it looks like we have a positive slope. And when I'm down here, I've got a positive slope. So it looks like this is going to be a relative maximum. And if I were to rewrite this part here, I might get x minus 1 over x squared, which means x equal 1 is a 0. And we know it's increasing. My feeling is that what you have is asymptotic behavior there, and then it rises up there, and then it decreases and becomes asymptotic to x equals 0 that way. What's going on? What's going to go on the other side? It is. Is this true? It's decreasing? No, this is wrong. This is negative there. Because when x is negative, this turns into a positive, but the bottom is always negative. So it's negative. So we've got negative, we've got a decreasing behavior. We know that it's got an asymptotic behavior towards 0 and toward there. So I think what we got there is something like that. Let's take a look at the second derivative. Let's use this as our first derivative. So the second derivative is going to be, let me rewrite that, x to the negative 2 plus 2x to the negative 3. Second derivative is going to be 2x to the negative 3 minus 6x to the negative 4th, or 2x minus 6 over x to the 4th. I'm not sure I did that right. Hold on. 2x to the negative 3 minus 6x over 4, 2x minus 6. Okay, there it goes. Alright, so indeed I did it right. And when does that equal to 0? Well, it's equal to 0 where 2 minus 6 is equal to 0, where 2x is equal to 6, where x is equal to 3. So at x equals x equals 3, there's a change in concavity. F double prime at our critical our values where I could change sign at 0 and 3. It looks like it's positive here, negative there, and when we're negative, it's always positive on the bottom. So it's negative. Okay, so this is consistent. This is concave down behavior through here. In here, we are also concave down, but then right here we switch and we switch to concave up behavior.